Have you ever faced this experience? Oh no, this semester I'm going to teach this killer subject again. According to the Law of Attractions book, we are actually sending a negative energy to our student, and they will also perceive it negatively. This will have an effect on their perception towards this subject, semiconductor devices. Let us take a closer look at semiconductor devices. Semiconductor devices such as diode, transistor, SCR, MOSFET are made of semiconductor material such as silicon and germanium. What makes this electrical core still relevant until today? The technologies are changing rapidly. We have been living, engaging, connecting with this semiconductor device for ages. Sensor circuits, PIC, microcontroller, and latest technology nowadays, Arduino and robotics, still have to start from the basic. That is to learn how a transistor functions as a switch to trigger any robotic motions. A theoretical and calculation course like this has to be injected with a new fresh way of teaching to stimulate interest towards students as well as to promote inspiring learning environment. I found out that these three methods work. They are storytelling, role play, and relating the uses of semiconductor devices to a real-life applications. The first method is by telling them a story. In this subject, the first questions that will across to the student's mind is, what is semiconductor devices? An explanation to this should be very clear. Let me give you one example by using this method. In our universe, everything is made up of matter. We can find different types of matter all around us. Everything seems to be made of smaller things. Cities have buildings, buildings have concretes have bricks in them. A brick is made up of silica, and a silica is made up of matter. But what is this matter made of? If we break a piece of brick in half, and then break it further half again, and then continually break it infinite number of times, we arrive at the point where we cannot break it any further. The question is, what is the brick particle made of? The only answer is atom. The structure of the atom consists of the electron shells going from innermost shell outwards. Here comes the basic idea, but important fact about an atom. The numbers of electrons in the outermost shells, which is called valence electron, determines the characteristic of the atom. If the number of valence electrons is within the range of 1 to 3 electrons, the atom inherits the conductive material characteristic. If the numbers of valence electrons is within the range of 5 to 8 electrons, the atom has the characteristic of an insulator. But what if the atom has 4 valence electrons? Then this is a semiconductor material. We learned this in our chemistry subject during our high school. This factual story I used to tell my students during my very first class every semester in this semiconductor device course. I can tell a series of stories sequentially from chapter 1 until chapter 2. This story that you create does not have to be serious as long as you support your story with animation or a video which you can access easily from the internet. The second method is by using a role play. The role play methods enable students to act out a situation given to them. They can fully utilize the space in their classroom and show their talent in acting. The lecture should not be boring. Find topics which are very difficult to visualize and understand, and they will have to perform in front of their own classmates. If possible, we try to get them involved as many as we can. It normally works since they were able to be creatively showing their talent in acting and trying to grasp the concept. You have created a moment with them, a moment for them to remember. The third method which I have used is to create awareness among students concerning the semiconductor device in our daily life. I agree that certain topics in our syllabus have a fixed percentage of theory and practical hours. But I found out that the practical work seems to be very basic, and if our students are not so initiative, then we will have a big problem. Normally, I would relate the practical works with an existing real daily life applications out there. To actualize this, I will organize an industrial visitation to any company or industry related to the semiconductor devices component. For instance, previous semester, we organized a visit to Radio Television Malaysia, RTM. In RTM, the students gained valuable experience and could realize the use of semiconductor in broadcasting equipment. This requires extra effort as an educator, but we have to be innovative and creative. This means we need to expand our knowledge beyond our notes, lab sheets, and pre-ready teaching materials available in our institutions, and just get ourselves out of a box. A true teacher will always find ways on how to improve their teaching skills. When I applied these three methods, the impact on my students seems to be very impressive. This is proven in their quiz and test scores. The term killer subject among students, of course, still lingered in our students' mind, but somehow they still find fun in learning this semiconductor devices subject.
This is amazing. With such a small component like this, we can learn a lot of things. As what we are doing now, theoretically, we know the most popular application of diode is rectification. Simply defined, rectification is the conversion of alternating current to direct current. As we have seen, this is exactly what a semiconductor diode does. The simplest kind of rectifier circuit, which is the half-wave rectifier, it only allows one half of an AC waveform to pass through to the lots. And this is fun and I love it.
As a conclusion, this sharing of experience emphasizes on how to tackle the killer subject mindset using these three methods. This is indeed a closer look on how the semiconductor device can be made interesting, relevant, and meaningful.